if you spend, any time at all looking at the tech world right now, it feels like there's this massive, very loud fight happening on the surface.
Oh, absolutely. It's deafening.
Right. Like you open any feed, any social media app, and there are just endless debates.
Usually about AI safety rules, yeah.
Exactly. Safety rules, regulations, existential risks, arguments over who should be allowed to build what.
Yeah, the volume is just turned all the way up.
It really is. It is incredibly noisy right now.
And the thing is, the sheer volume of those debates, it takes up almost all the oxygen in the room.
Yeah.
Like they dominate the headlines, they feed the algorithms, and it creates this illusion that the entire industry is just, paralyzed.
Right, paralyzed by theoretical arguments.
Exactly. Arguments about the distant future.
But while everyone is looking at that messy fight on the surface,
Yeah.
there is an entirely different reality playing out quietly in the background.
A much more lucrative reality.
Definitely. Because while some parts of the industry are fighting over the rules, other companies are just quietly cashing massive nine-figure checks.
Yeah.
And that is exactly what we are going to look at today. We are going to ignore the noise, and we are going to follow the money.
Which is honestly the best approach. Following the money is, it's the single most reliable way to understand any major technological shift.
Because the money doesn't care about the debates.
No, capital doesn't care about philosophical debates at all. Capital cares about physical infrastructure, right? It cares about the immediate commercial applications that are being built right now.
And the money we are following today for this deep dive is, it's staggering.
It really is.
We're diving into some recent source material. It's a briefing on the infrastructure and video intelligence funding surge. And our mission today is to unpack two recent, absolutely massive funding rounds.
Rounds that basically reveal exactly where the AI industry is heading next.
Exactly. We are talking about single funding rounds approaching $1 billion.
Yeah, which is just a wild amount of money for a single round.
It's hard to even wrap your head around. But what is so fascinating about these investments is that they point to a future built on something called native video understanding.
Right.
So we are going to unpack exactly why native video models matter so much and how they are about to change everything from enterprise automation to, how you search for content.
Because we are at a really critical inflection point here.
Yeah.
Like you said, the sheer volume of the money is eye-watering. But the real story underneath that is about industry consolidation.
Consolidation and, I guess, technological maturation.
Exactly. We are witnessing this fundamental shift in how artificial intelligence processes the real world.
Moving away from text.
Right. Moving away from abstract text and static images and moving toward a true temporal understanding of physical reality.
Which is a huge leap.
It is.
So let's start with the macro trend outlined in our sources. The big takeaway is that the pool of winners is shrinking rapidly.
Yes.
Broad data shows that AI infrastructure and compute-related startups are still pulling in these outsized checks. But a diminishing number of companies are capturing a much larger share of the total funding.
Yeah, the concentration of capital is intensifying.
All right. We are seeing fewer deals, but the deals that do happen are astronomical.
Because we are watching the transition from the exploration phase to the scaling and dominance phase.
What does that mean exactly, the exploration phase?
Well, in the early days of any revolutionary technology think of the early internet or even the dawn of the automobile.
Okay.
Capital is relatively cheap and investors spread their bets. They fund 100 different small companies with 100 wild ideas.
Just throwing spaghetti at the wall.
Exactly. A scattergun approach. You're just hoping one of those garage-based startups hits the jackpot.
Right.
But the source material is indicating that the exploration phase for foundational AI is functionally over.
Okay, I have to push back a little there, or at least clarify, because I look at that shrinking pool of companies getting all the money, and it feels like a massive bottleneck to me.
It is a bottleneck, yeah.
Like, isn't the AI boom already turning into a closed club where only the absolute giants can play?
It absolutely is.
If the barrier to entry is now, $1 billion just to get a seat at the table, we are no longer in the era of two kids in a dorm room changing the world.
No, those days are done for foundational AI.
Wow.
Because the fundamental architectures have proven themselves and the cost of entry has just skyrocketed.
Right.
You cannot build the next generation of foundational AI on a couple of laptops. You just can't.
Because of the compute power.
The compute power, the specialized silicon, the massive data pipelines,
Yeah.
the physical infrastructure demands hundreds of millions of dollars before you even train a single usable model.
Which is crazy to think about.
It is. And investors look at that landscape and they realize they cannot afford to fund 50 competing infrastructure companies.
Right. Nobody has that kind of money.
So they are forced to pool their resources.
Right.
They concentrate all that capital into a very small, highly capitalized vanguard.
And there's a geographic detail in the source material that is impossible to ignore here.
Oh, the U.S. dominance.
Yeah. Nearly all of this concentrated capital is going to companies based in the United States.
Yes.
We are talking about the vast majority of global infrastructure funding funneling into a single country.
Which has profound implications.
Mm-hmm.
When the actual engines powering the next generation of artificial intelligence are geographically monopolized like that,
Yeah.
it means the foundational layer of the next digital revolution is overwhelmingly American-based.
Great.
The physical hardware, the data centers, the mega rounds of funding, it's highly, highly localized.
So the stakes are shifting. The infrastructure required to run these models is becoming a strategic asset.
Almost like a national utility.
Exactly. A national utility. We aren't just talking about software companies anymore. We are talking about heavy industry.
Yep.
And that brings us to exactly who is receiving these massive checks. Because to understand why the money is concentrating so intensely, we really have to look at the backbone of the entire operation.
Foundational layer.
Right. So our source highlights two specific startups that closed massive rounds within days of each other.
Yeah.
The first one is an AI infrastructure company, and their entire focus is on training and running large models efficiently at scale.
Which is key. Efficiently at scale.
Yes. And they closed a 9-figure funding round that the text specifically notes is approaching the $1 billion mark.
Just an incredible amount of capital.
But the detail that completely jumps off the page for me is who actually wrote the check.
Right, the lead investor.
The round was led by the venture arm of a major energy sector investor.
Yeah, and that detail cuts entirely through the noise we were talking about earlier.
It really does.
Traditional energy players are now placing serious billion-dollar bets on AI compute demand.
This is where my brain just completely shifted gears. Because you have to stop thinking of AI as just software.
Right.
We think of apps on our phones or web interfaces, and it all feels completely weightless.
Like it just lives in the cloud.
Exactly, residing in some invisible cloud. But building these models is practically identical to building massive steel factories.
It's a great analogy.
And you cannot run a steel factory without a staggering, continuous supply of industrial power.
No, you can't. The cloud is a very misleading metaphor, honestly.
Because it sounds so light and fluffy.
Right, but the cloud is actually a massive, windowless concrete building sitting on hundreds of acres of land.
Filled with servers.
Yes. Inside that building are thousands of specialized server racks generating so much heat that they require industrial-grade, closed-loop, liquid cooling systems.
Just to keep from melting.
Literally just to keep the silicon from melting down.
Yeah.
And operating that facility requires an unfathomable amount of electricity.
But I'm still trying to wrap my head around an energy company leading a tech infrastructure round. Because usually you see Silicon Valley venture capitalists fighting for that spot, right?
Typically, yes.
The fact that a traditional energy provider stepped in means they view this as their own supply chain.
Oh, absolutely.
Yeah.
The energy sector realizes that artificial intelligence is going to be their largest customer for the next century.
Wow. Their largest customer.
Easily.
Yeah.
The phrase in the source material is training and running large models efficiently at scale.
Right. Training and running.
Those are two distinct phases of the AI lifecycle. And both require different but equally massive power draws.
Let's break that down. Training the model versus running the model.
Okay, so let's look at the physical reality of training first.
Okay.
Feeding a model petabytes of data, which is essentially the entire digitized output of humanity.
Just reading the whole internet.
Yeah, reading the internet. It requires the neural network to process all of that,
Yeah.
adjust its internal weights, and learn the statistical relationships across all that information.
And that takes a while.
Training a single massive model can take several months of continuous, uninterrupted computation.
Months.
Across tens of thousands of specialized GPUs working in tandem.
Just grinding away.
Exactly. And the energy draw for that single training run is roughly equivalent to the power consumption of a small city over that same time frame.
That is insane for one model.
For one model.
Yeah.
It is pure brute force mathematics happening billions of times a second.
Okay, so that's training. It eats a small city's worth of power. What about running it?
Right, the second phase, running the model, which the industry refers to as inference.
Inference, okay.
Inference happens every single time you type a prompt into an AI tool or ask it to summarize a PDF or generate a line of code.
So every single time I hit enter, a physical server somewhere in the world has to wake up and do the math.
Exactly. Now, a single query uses a tiny fraction of the power of training,
Sure, because it's just one question.
but you have to aggregate that across hundreds of millions of users interacting with these tools all day, every day.
Oh, right.
When you integrate AI into every piece of enterprise software, every search engine query, every customer service interaction,
The numbers get huge.
the aggregate energy demand for inference eclipses the training phase.
Wow. Because it never stops.
It never stops. So when an infrastructure company promises to train and run these models efficiently at scale, they aren't just solving a software architecture problem.
They're solving a power problem.
They are fundamentally solving an energy distribution and thermal management problem.
So the energy players are looking at this landscape and they're realizing that backing the infrastructure that processes AI efficiently is like the ultimate hedge for them.
It's brilliant on their part.
The battle for AI supremacy isn't happening just in the code repositories.
No,
It is happening on the power grid. Like every time you use one of these tools, you are directly interacting with heavy machinery that requires a dedicated line to a power plant.
exactly. So a near billion-dollar check from an energy investor is a perfectly logical move.
Because compute is the new oil.
Compute is the new foundational commodity, yes. And extracting it requires massive, uninterrupted energy generation.
Okay, so if infrastructure and energy are the heavy machinery, what exactly is this machinery being built to process?
That is the big question.
Because you don't build a billion-dollar factory just to admire the conveyor belts.
No, you build it because you have something to manufacture.
You build it because an entirely new class of product demands it. And that leads us directly to the second startup in our source material,
Yes.
which is honestly the true star of today's deep dive.
This is where we transition from the infrastructure to the application layer.
Right. So this second company raised a 9-figure Series B round.
Also massive.
But this round was led by a well-known enterprise venture firm.
Yeah, different type of investor.
Exactly. So we have the energy sector securing the physical infrastructure and the enterprise sector backing the application.
Right.
And the application they are building is what completely blew my mind. They are building models that process video natively.
Natively processing video.
Yes. The source draws a really sharp critical contrast here.
It does.
The old approach treats video as a series of disconnected images, but the new approach processes video natively, tracking actions and cause and effect over time.
That is the fundamental shift right there.
Okay, I need to pause here because this concept really tripped me up when I was reading it.
It's counterintuitive at first, yeah.
Because I always thought a video was literally just a series of disconnected images played really fast.
Sure.
Like if I record a video on my phone at 60 frames per second, I am just capturing 60 photographs every second, right? It's just a high-speed flipbook.
That's how we experience it, yeah.
So why does the AI care if it looks at the file natively or as a massive folder of photographs? Like, what is the actual mechanical difference?
Okay, the mechanical difference represents a complete architectural overhaul of how the AI retains and processes information.
Okay, walk me through it.
Let's look at how traditional AI handles that flipbook you mentioned.
Right, the folder of images.
If you feed a standard computer vision model a video, it basically pauses the file, looks at frame 1, and registers, I see a glass sitting on a table.
Okay.
Then it dumps that frame from its active memory, skips ahead to frame 50, and registers, I see broken glass on the floor.
So it's just looking at isolated snapshots.
Exactly. It is merely performing static image recognition on isolated moments in time.
Right, so it can perfectly identify the shattered glass in frame 50, but it is entirely blind to the concept of gravity.
Yes. Or the physical force that caused the glass to shatter in the first place.
So it knows the glass is broken, but it doesn't know why.
It is decoupled from physics entirely. To a traditional image-based model, the intact glass and the shattered glass are just two statistically unrelated images that happen to exist in the same data set.
They just happen to be near each other.
Right. But the source explicitly highlights this phrase, tracking actions and cause and effect over time.
Cause and effect.
Yes, for an AI to understand that the glass didn't just spontaneously teleport to the floor in pieces.
Which would be magic.
Right. It must retain the memory of frame 1 while processing frame 2, frame 3, and so on.
It has to hold on to the past.
It has to observe the hand striking the glass, calculate the velocity of the fall, and recognize the structural failure of the material upon impact.
Okay, I think I get it. The old way is like handing the AI a flip book that has been dropped on the floor, right?
Yeah.
And making it guess the story from random shuffled pages. Like, it can tell you there is a picture of an intact car and a picture of a crashed car, but it has no idea how one became the other.
Exactly. It doesn't see the crash.
But the native way is teaching the AI to sit back, watch the movie from start to finish, and actually comprehend the underlying plot.
And comprehending the plot requires an implicit understanding of the rules governing reality.
Because you can't understand a crash without understanding momentum.
Exactly. Cause and effect are the operative words in our source. Analyzing a static photo of a shattered glass and labeling it broken glass is a solved problem. We've been able to do that for years.
Right, bounding boxes.
But analyzing a fluid video to understand what shattered the glass, how the object fell, and why the material failed, that requires the model to develop an internal representation of physics.
Physics, temporal flow, narrative sequence.
All of it.
So the architecture of the model itself has to be built differently.
Very differently.
It needs a memory system that holds the past in tension with the present frame.
Natively processing video means the foundational language of the model is time and motion.
Not just pixels.
Right. It is not translating a video file into 1,000 separate JPEG images, running image recognition on each one, and then trying to stitch them back together with external code.
Which is super inefficient anyway.
Extremely. With native video, the neural network's architecture is fundamentally designed from the ground up to process sequential, continuous data.
Okay, that makes perfect sense on a technical level.
Yeah.
But we have to look at who wrote the check.
Right. The enterprise VC.
A 9-figure Series B led by an enterprise venture firm. Why does an enterprise VC care if an AI understands the physics of a falling glass?
It's a great question.
Because understanding cause and effect in a video feels like an incredible leap for robotics or, Hollywood visual effects.
Sure.
But the source explicitly states this translates into massive, immediate business impact.
Well, think about it. The world of enterprise business is defined by physical actions and sequential workflows, not just static spreadsheets.
Sure.
The text notes that controlling efficient infrastructure and native video understanding positions these companies to power the next wave of agentic and multimodal products.
Okay, let's clearly define those terms.
Yeah, they get thrown around a lot.
Because multimodal and agentic get used as buzzwords constantly.
They do.
My understanding of multimodal is that the AI is no longer restricted to a single type of input.
Correct.
Like, it can see a video, listen to the audio track, read any text on a screen, and output a spoken summary or a new visual graphic.
Right, it operates across multiple modes of reality.
It's not just text in, text out.
Exactly. It processes information across different sensory inputs simultaneously, much like a human does.
And then there is agentic.
The term agentic is even more critical for the enterprise sector.
What does it actually mean?
An agentic AI is not a passive chatbot waiting for a prompt. It acts as an autonomous agent.
So it does things on its own?
Yes. You give it a high-level goal, and it independently navigates software tools, processes incoming information, makes tactical decisions, and executes actions to achieve that goal.
So an agentic AI is a system that actually takes control of the mouse and keyboard to execute tasks.
Literally, yes.
Now, when you combine an agentic system with a native video model that understands physical cause and effect, I can start to see why an enterprise VC dropped 9 figures.
It's a game changer.
Yeah.
Let's apply this to the enterprise automation example mentioned in the source.
Okay.
Currently, if you want to automate a factory floor, or even automate a complex digital workflow where a worker clicks through 5 different software applications.
Like data entry stuff.
Yeah. It requires engineers to write massive amounts of brittle custom code.
You have to map out every single variable.
Every single one.
If the red lever is pulled, execute the script. If the barcode scanner fails, trigger this alarm.
Exactly. You are hard-coding every possible physical and digital interaction.
Which takes forever and breaks constantly.
It is incredibly expensive and time-consuming. But if you have an agentic AI equipped with native video understanding.
Oh, wow. You don't have to write the code.
No, you don't.
The AI just watches the video feed of the factory floor and learns the workflow by observing the physical actions in real time.
Yes. It intrinsically understands that pulling the red lever is the cause, and the conveyor belt stopping is the effect.
Because it understands time and physics.
It creates its own internal map of the process just by observing the temporal flow of events.
That is wild.
It recognizes that if a worker drops a tool, that action is a deviation from the established causal chain.
It knows a mistake happened without being programmed to look for that specific mistake.
Exactly. You transition automation from a highly specialized coding problem into an observation problem.
So you just point a camera at a human performing a complex task?
You let the AI watch the video feed for a week, and it understands the sequence of actions well enough to replicate them or optimize them,
It learns through apprenticeship just by watching.
just like a human trainee would.
And because it is an agentic model, once it understands that causal chain, it can take action to improve the workflow or flag inefficiencies without any human intervention.
That is the translation layer between physical observation and digital execution.
Okay, that makes a lot of sense for automation. But the source also brings up video search as a primary application.
Yes, video search is huge.
How does a native video model revolutionize search? Right now, if I want to find a specific video in a massive database, say on YouTube or a corporate drive, I'm entirely reliant on typing in keywords and just hoping the person who uploaded the file tagged it correctly.
Right, because current video search is essentially blind to the video itself.
What do you mean?
It searches the metadata, the titles, the descriptions, the user-generated tags.
Oh, right.
The search algorithm has zero comprehension of the pixel data inside the file. It only knows what a human has typed into the description box.
So if a compliance officer at a massive retail chain needs to find a specific safety violation across, thousands of store cameras,
Yeah.
and no one manually tagged the video with safety breach, that footage is practically invisible to the search engine.
It's completely hidden. Imagine the daily workflow of that compliance officer right now.
Okay.
They are tasked with auditing safety protocols across 500 loading docks. Under the current paradigm, they are spot-checking random hours of footage, fast-forwarding, trying to catch a violation by pure chance.
That sounds miserable, an impossible, soul-crushing task.
It is. But with a native video model that tracks actions and cause and effect, the search paradigm flips entirely.
Because the AI can actually watch the footage.
It can comprehend every single frame of those thousands of hours of footage simultaneously.
So how does the search work then?
The compliance officer doesn't search for the text tag safety breach. They query the system by describing a physical action.
Like what?
They ask the system, find me every instance where a worker walked under a suspended pallet during the unloading process.
Oh, wow.
The AI isn't looking for text. It is looking for a highly specific sequence of physical events.
Because it understands the concept of a suspended load.
Yes.
It understands the physical trajectory of a human walking.
Yes.
And it understands when those two causal chains intersect inappropriately.
Exactly. It searches the physical reality of the video data.
That is incredible.
You could ask it, show me every time a customer picked up the blue product, examined the back of the box for more than 5 seconds, and then placed it back on the shelf.
Which is a highly complex string of physical causes and effects.
And a native video model can isolate those exact moments instantly across petabytes of unstructured footage.
The business intelligence value of that capability is just astronomical.
It really is.
You could audit an entire retail chain's customer behavior without employing a single human reviewer.
Or think about medicine. You could review thousands of hours of surgical footage to ensure absolute adherence to medical protocols based on the physical movements of the surgical team.
You are taking video, which has historically been unstructured, messy, heavy data,
Very heavy.
and transforming it into a perfectly searchable, structured database of human action.
And this circles us perfectly back to the profound synergy between the two startups mentioned in our source material.
Right, the infrastructure and the application.
You cannot run these massive agentic native video models without the highly efficient energy-backed infrastructure discussed at the beginning of our deep dive.
They are completely symbiotic.
Exactly.
Because processing video natively, maintaining the memory of previous frames, and calculating physics and time, that has to require an exponential leap in compute power compared to processing static text or still images.
It's night and day. You need the heavy machinery.
Right.
You need the gigawatts of power and the liquid-cooled data centers we talked about.
That is why these two specific sectors, efficient compute infrastructure and native video models, are absorbing nearly all of the massive capital right now.
The investors understand that native video models are the killer application of the next decade.
And the high-efficiency infrastructure is the mandatory toll road every single company will have to pay to use.
Precisely. You want to run the model, you pay the toll.
Now, our source material doesn't just give us a snapshot of the technology today.
No, it looks ahead.
It provides a very specific, aggressive forecast for the immediate future.
And the timeline outlined in the briefing is perhaps the most striking element of the entire document.
The text states, and I quote, "Over the next 3 to 6 months, expect more mega rounds concentrated in infrastructure and specialized model companies, and expect video understanding in particular to move quickly from research demos into real commercial products."
3 to 6 months.
3 to 6 months. Transitioning from a research demo to a commercially viable enterprise product in that time frame is incredibly fast.
It is moving at light speed, even for traditional software development, let alone complex hardware and deep learning infrastructure.
Right, because normally this stuff takes years.
Exactly. That timeline reveals an enormous amount about the current maturity of the underlying technology.
It means it's ready.
It's ready, but it reveals even more about the intense pressure coming from the capital markets.
The investors are getting impatient.
Exactly. When an enterprise VC leads a 9-figure round at a multi-billion-dollar valuation, they do not want to see a fascinating theoretical demo at a tech conference in 2 years.
They don't care about the demo.
They expect immediate commercial deployment and revenue generation.
We are witnessing the brutal transition from hype to utility.
That's a perfect way to phrase it.
Over the last 2 years, the industry has been mesmerizing us with what generative AI could do in a controlled sandbox environment.
Making funny images, writing poems.
Right. But when enterprise venture capital takes the steering wheel, the entire mandate changes overnight.
The new mandate is demonstrate exactly how this native video model saves a Fortune 500 client $20 million in operational costs this quarter.
This quarter. Wow.
Yeah.
But if we are truly moving from research demos to real commercial products in less than half a year, how does that rollout actually manifest for the end user?
What do you mean?
Well, we aren't just going to wake up in December and suddenly find that our software is sentiently watching everything we do, right?
No. It will be a rapid but integrated deployment.
Okay, so what does that look like?
You will start seeing these native video models embedded seamlessly into the enterprise tools you already use every day.
Like what? Give me an example.
Okay, take video editing suites.
Oh.
They will introduce features where you can automatically cut a montage of all the high-tension moments where the protagonist is physically isolated.
And the software will just do it.
The software will parse the emotional and physical reality of the raw footage to build a sequence because it understands the physical space and the actions.
Oh.
Or think about customer service platforms. They will evolve from reading text transcripts to analyzing the video feed of a customer unboxing a defective product.
So if I'm trying to return something, I just hold it up to my webcam.
Yes. And the AI will instantly diagnose the mechanical failure based purely on observing the physics of the broken component in the video.
Because it knows how the component is supposed to function physically.
Exactly.
And the consolidation we talked about earlier is exactly what enables the speed, isn't it?
It is the driving force.
Because the pool of mega winners is shrinking, these rollouts aren't going to come from 1,000 fragmented startups struggling to find server space.
No, they couldn't possibly move this fast.
The deployment is going to be driven by a few highly capitalized giants rolling out fully formed enterprise-grade video intelligence at massive scale.
Extreme consolidation forces extreme velocity.
Because they have the resources.
When you have billions of dollars concentrated in a single entity, that company possesses the resources to brute force engineering challenges that historically took years to solve.
Right.
They can pre-purchase the massive compute clusters, they can secure the long-term energy contracts from the power grid, and they can deploy the technology globally almost overnight.
It really paints a cohesive, interconnected picture of the industry right now.
It does. Everything is linked.
Because we started by looking at the noise, right? The safety debates, the regulatory arguments, the distractions on the surface.
Yep.
But when you follow the money, you uncover a very clear, very quiet, and incredibly well-funded pipeline being constructed beneath the surface.
It's all about the underlying structure.
So let's trace the complete journey we just took through the source material.
Sure.
We started by identifying the macro trend. AI funding is rapidly centralizing into a few mega rounds, and that capital is overwhelmingly remaining in the U.S.
Which means the foundational infrastructure of the future is becoming a highly consolidated geopolitical asset.
Exactly. We then examine the foundational bets being made. Specifically, an infrastructure startup raising nearly $1 billion backed by a major energy sector investor.
And that proved that the future of AI compute is inextricably tied to the physical power grid and industrial energy generation.
Right. The realization that AI development is basically heavy manufacturing, reliant on massive physical data centers and energy distribution, it grounds the entire conversation in reality.
It stops being abstract software and starts being heavy industry.
We then explored exactly what that heavy machinery is being built to process.
The native video models.
The cutting-edge bets are being placed on specialized models, primarily native video understanding. We are moving from an era of AI that merely recognizes static, isolated images to an era of AI that genuinely grasps cause and effect over time.
Is moving from identifying a broken glass to understanding the physical forces that caused it to shatter.
And that technological leap is the prerequisite for autonomous agentic tools that can learn enterprise workflows simply by observing them, or instantly search petabytes of video data for specific human actions.
It unlocks everything.
And according to the forecast, this is all moving from the laboratory to the commercial market in the next 3 to 6 months.
It is a comprehensive, highly accelerated roadmap of the near future, constructed entirely by analyzing where the institutional capital is flowing right now.
It is absolutely fascinating and honestly a little bit staggering to realize how quickly the underlying architecture of our digital world is being rebuilt.
It is. But if we pull back and view this transition through a wider lens, it leaves us with a profound implication to consider.
What's that?
If AI is rapidly evolving from identifying static images to natively understanding physical cause and effect, tracking actions in real-time video, and remembering the temporal flow of events, how will this fundamental shift alter our relationship with reality itself?
Oh, wow.
Consider the end game of this technology. When a system can perfectly parse the cause and effect of any video it processes, it will inevitably transcend being a mere enterprise tool used for factory automation or compliance auditing.
What does it become?
It will become an ultimate, objective observer of human action.
A completely objective observer of the physical world.
We are building systems designed to watch physical reality unfold and map the exact causal chains of our behavior, frame by frame, without human bias, fatigue, or memory degradation.
It doesn't blink.
It doesn't blink and it doesn't forget. It raises an extraordinary question. What happens to our society when an artificial intelligence understands the sequence, the physical dynamics, and the consequences of our actions better than we do?
Yeah.
What happens when it can observe a complex situation, a traffic accident, a surgical procedure, a manufacturing failure, and instantly identify the precise cause of an outcome that a human observer with our flawed memory and limited perception would completely miss?
Because we just can't process that much temporal data.
Exactly. We are not just teaching machines to generate text. We are teaching them to fluently read the foundational language of physical reality.
A machine that reads the causality of our world better than we do. That is certainly something to mull over.
Yeah.
Well, that concludes our deep dive into the infrastructure and video intelligence funding surge. Thank you so much for joining us on this exploration.
It was a pleasure.
Keep your eyes open and watch the news over the next 3 to 6 months for those mega rounds. When you see them, you will know exactly what kind of future they are building. Until next time.